All right, let's go ahead and get started. Welcome to our webinar today. My name is Justin D'Souza. I'm a quantitative specialist here at Statistics Solutions. During today's webinar, we will be discussing how to conduct and interpret correlation tests. My colleague Melissa is going to assist me with questions during the webinar. So if you have any questions about the services that our company can provide, you can type those into the chat box or the question and answer box. And at the end of the webinar, I will be doing a Q&A session for any additional questions about today's topic or the services that we provide. We will be sending everyone a copy of the webinar as well as a copy of the PowerPoint presentation. Go ahead and dive in. So I'll start off by giving a brief overview of the services that our company Statistics Solutions provides. Then we will dive into the topic for today about running and interpreting correlational analyses. I will provide a demonstration in SPSS with sample data, and we will conclude with a summary and question and answer session. Our company, Statistics Solutions, provides assistance with every part of the dissertation process. So the way our company works is we will assign a methodologist to you, and we will assign a literature review specialist. We do have methodologist specialists that focus on both quantitative and qualitative dissertations. So we help you develop your topic, frame your research questions, narrow down a theoretical framework, help determine your research design, and figure out what analyses are best to address your research questions. So if you've hit a roadblock in the dissertation, you can see all the different bullet points of things that we can assist with. You can give us a call at 727-442-4290 for a free consultation. So for today's topic, we're focusing on correlational analyses. And before we jump into correlations, I think it's good to build a foundation for the different types of variables you can have if you're addressing a research question. So we have continuous, nominal, and ordinal variables. Almost any type of variable can be categorized into one of these variable types. So the continuous variable, it has the word continuous, and that's synonymous with a variable that falls on a continuum. So it has a range of values. And examples of this include test scores, temperature, weight, BMI, height, and also composite scores on a previously validated instrument. So if you have a series of Likert scale questions, maybe ranging from 1 to 5, strongly agree to strongly disagree, once you take an average or a sum of those Likert scale questions, that resulting variable you have is now continuous, as you can have decimals as possibilities potentially. The anchors of the scale go beyond the Likert scale at that point. So if 1 is strongly disagree and 5 is strongly agree, and you take an average of a series of items, you can have 2.6 or 4.2 as possibilities. Your variable is now a continuous measurement. A nominal measurement is a categorical variable. So it's a variable that falls into distinct and discrete categories. Examples like this include gender, ethnicity, or passing and failing of an exam. There's not an intrinsic order to these variables. There's no hierarchy. You have male, female, you have white, black, Asian, Hispanic, passing and failing of an exam. Those are 2 discrete possibilities. So that would be a nominal example of a variable. An ordinal variable is similar to a nominal variable. It's actually a subset of a nominal variable, but your variable can have an intrinsic order to it. So a variable like education, where you have less than high school, bachelor's, master's, PhD, there is a natural progression education, and it's a multiple choice response. So this would be an example of ordinal variable. Another example, kind of tying back to the continuous example, would be looking at a single Likert scale item or a single ordinal item survey. So strongly agree down to strongly disagree. If you're only looking at this question on its own, this is an example of an ordinal variable. So now we can get into specific types of analyses. There are parametric statistics and there are non-parametric statistics. Parametric techniques make assumptions about the distribution of your population and where your sample was derived. Usually this assumption is that your data follows a normal distribution. So I'm sure everyone at some point has seen a bell-shaped curve. That is the assumption that typically carries over into a parametric analysis. You'll want to make sure that your data follows a bell-shaped curve. And there are many ways to do that, which we will go through later in the presentation. The other assumption when running parametric techniques is that your variable is typically going to be continuous. So you don't want to be using nominal or ordinal variables when using parametric techniques. Non-parametric technique is a statistical analysis that doesn't make specific assumptions about data. So this is an example where you don't necessarily need to have a normal bell-shaped distribution. Your distribution can follow any shape or form. Continuous variables are also not a requirement doing non-parametric analyses. So this allows you to use both ordinal and nominal variables. So focusing on the parametric analyses, we're making the assumption that the data follows a normal bell-shaped distribution. There are many ways to check for normality. So I would recommend checking with your school, either your checklist or check with your methodologist who may be in your committee, and see if they have a preference. There are many ways. You can use a Shapiro-Wilk test, a Kolmogorov-Smirnov test. You can even examine the skewness and kurtosis of your variables, and you can examine it visually through scatter plots or histograms. So if the data does not meet the normality assumption, then you can use non-parametric techniques as an alternative or a backup. My preference is to use either a Shapiro-Wilk or a Kolmogorov-Smirnov test because these give you definitive evidence statistically that normality is not supported or that it is being supported. I prefer that versus histograms or scatter plots because when you interpret normality visually, it's very subjective. Typically, you can see if there is a bell-shaped curve, but there might be slight deviations. And it's difficult to pinpoint definitively, is it following a normal distribution? So I prefer using tests of significance versus a visual aid. This third bullet point here is a good point to keep in mind if you have a large sample size. So if you do run a test of normality and the assumption is not met, perhaps you have a large sample size. You might have more than 50 cases, and I have provided a citation here in which Howell 2013 states that violations of normality are not problematic when you have a large sample size. So if you have at least 50 cases, then you can still proceed with using parametric analyses. You may not even need to shift to non-parametric. That is something to keep in mind. So on this slide, we have the different types of correlational tests, and you can see what corresponds to a parametric technique and what corresponds to a non-parametric technique. So under the parametric family, we have Pearson correlations, which are used when you're looking at the association between two continuous variables. We have a point biserial correlation, which tests the association between a dichotomous variable and a continuous variable. The non-parametric techniques we have are Spearman correlation and a chi-square test of independence. So a Spearman correlation is used when you have at least one ordinal variable. It can also be used when you initially propose a Pearson correlation and the normality assumption is violated. You can then move to a Spearman correlation as a backup. I-squared test of independence is used when you're checking the association between two categorical variables or two nominal variables. Something like if you're testing the relationship between gender and passing and failing a biology exam. If those are both categorical variables, we have gender, male and female, and passing and failing of an exam. You could use a chi-square test there to see if there is a relationship between gender and passing and failing. As far as interpretation, the first thing you want to look at is the p-value. So you want to identify whether the correlation is a significant relationship. And that is signified by a p-value being below 0.05. That is the most common threshold used in statistics. You might see a different one if you read a different textbook, or if you're doing Bonferroni corrections, which is a topic for a different day. But Bonferroni corrections would then lead you to using a lower p-value. So most of the time it will be 0.05. Then you can use Cohen's standard to interpret the strength of your correlation coefficients. So here I've provided Cohen's standard. So first you look at the p-value, figure out if it's significant or not. Then you look at the correlation coefficient. And if it's between 0.1 and 0.29, you have a small association or relationship. If it's between 0.3 and 0.49, you have a medium or moderate association. And then if you have a coefficient greater than 0.5, then you have a large association relationship. So a Pearson correlation is probably the most predominantly used parametric technique here. It's what most people propose to use, assuming that you have a normal distribution. So I've highlighted that it's a parametric technique. You need two continuous variables. You first want to check for normality with one of these tests, or using skewness kurtosis or histograms. If the assumption is not met, then you might want to consider using a Spearman correlation as an alternative. And if your sample size is large, then we're referring to that citation earlier that violations of normality are not problematic if you have a large enough sample size, typically greater than 50 cases. Here are the SPSS commands for running a correlation, and we will go through that in just a second. A point biserial correlation is used when you have a dichotomous variable and a continuous variable. So because you do have a continuous variable here, you will want to check for normality first. And if normality is not supported, you can use a non-parametric technique here called the Mann-Whitney U-test. Here are the SPSS instructions for a point biserial correlation. And then a Spearman correlation is the non-parametric technique when you have at least one ordinal variable. And because it's non-parametric in nature, you don't have strict assumptions to check, linearity or normality, homoscedasticity, things like that. Non-parametric techniques typically don't have many assumptions to check, and normality is definitely not one of them. So here are the instructions for running a Spearman correlation. And finally, a chi-square test of independence is used when you're checking for the relationship between two nominal variables. Like I said, age or gender and ethnicity, or gender and passing failing exam. This is the type of test used. Everything needs to be categorical. And here are the instructions for running a chi-square test. Ultimately, you want to identify if you are using a correlational design, um, then you can use correlational analyses to address those research questions. It's important to note that when you do correlations, you don't necessarily need an independent and dependent variable. You just need two variables of interest. Once you have an independent and dependent variable, you might want to consider using regression analyses because you have a definitive predictor and you have a criterion variable. So you have independent and dependent variables of interest. When you're doing a two-way association with correlations, you do not need to identify predictors and criterions or independent and dependent. Once you've selected your analysis, you want to check for the parametric assumptions of those analyses, primarily normality. And then you can shift to a non-parametric technique if the assumption of normality is violated. Let's dive into an example here. And here I have a spreadsheet of 32 different car models. You can see Chrysler, Hornet, Mazda, and we have different statistics for each of these car models. Today, we're going to look at miles per gallon and weight of the car. So weight was measured in metric tons, miles per gallon. Straightforward, how many miles per gallon does each car obtain at its peak? So what we're going to test is there a significant relationship between the weight of the car and how many miles per gallon received? So again, before you start, let's look at the different ways of checking for normality. One way you can check is by going to descriptive statistics and then explore. And once you're in this menu, you can move your variables of interest to the right box here, the dependent list, and you want to go to plots, the right side there, and check mark this box right here, normality plots with tests. This is going to give you a Shapiro-Wilk and a Kolmogorov-Smirnov test. You can click OK. This is the output that we receive. Scrolling down past the first two tables, you'll see tests of normality right here. And tests of normality, this is a rare time in statistics where you do not want to see significant results. So you don't want to see a p-value lower than 0.05. So what these two tests are doing is it's comparing your test data. So it's comparing miles per gallon and weight to a true bell-shaped curve. And if you have significance, that means that your data is significantly different than a bell-shaped curve, which is not what we want. So here we can see that the p-values are all greater than 0.05. The p-values are in the significance column right here. So regardless of which test we use, the Kolmogorov-Smirnov or the Shapiro-Wilk, I use both just as often. I don't have a preference. You can go with either. You can see that all the results are non-significant, which is good. That means our data met the normality assumption. That's one way to check it. A second way to check it is by looking at skewness and kurtosis. So you can actually see that right here, skewness and kurtosis. And what's a red flag is if these values go beyond 2.00 or if they are less than negative 2.00. So we can see that both skewness and kurtosis fall in the 2 to -2 range. It means that it approximately follows a normal distribution. That is a good thing. So that's our second way to check for normality. The third way would be developing histograms visually. So if you go to descriptive statistics and then frequencies, we'll put miles per gallon and weight in this right box. We'll go to charts and histograms. Okay. You can see that approximately these variables do follow a normal distribution. Okay, there is a slight skew here. Obviously, this doesn't fully look like a normal bell-shaped curve, but based on the tests of significance, this is definitive proof that we have met the assumption. Okay, so because we have met normality, that gives us the ability to proceed with Pearson correlation. These are both continuous variables. Miles per gallon, you can see we have decimals as possibilities in both miles and weight. So this gives us the ability to run Pearson correlation. I'm going to go to Analyze, Correlate, and Bivariate, doing a two-way relationship, which is what bivariate means. Then I'll put in weight and miles per gallon. And you can see at the bottom here, I have Pearson correlation checkmarked. That will be the default option. So say that the assumption of normality is not met, then you can run a Spearman or a Kendall's tau. I didn't mention Kendall's tau because I don't see it used very often. I see a Spearman used as the alternative more than a Kendall's tau. But if the assumption of normality was not met, then you can check mark Spearman correlation right here. And then we can click OK. So this first correlation box is for the Pearson correlation. Now coming back to the presentation, in terms of interpretation, you first look at the p-value, and then you look at the correlation coefficient. Okay, so the p-value is less than 0.001. That is a significant relationship because this p-value is lower than 0.05. In fact, it's lower than 0.001, so it's very significant. Then we look at the sign of the correlation coefficient. So the sign is negative here, meaning that as one variable is increasing, the second variable tends to decrease. So as weight increases, miles per gallon of the car tends to decrease. That also works vice versa. So as miles per gallon on the car increases, the weight tends to decrease. We take this 0.868 and we compare it to Cohen's standard right here. 0.868 falls in this threshold above 0.50. So that means we have a large or strong association between weight of the car and miles per gallon. Another thing I like to do is develop a scatter plot between the variables of interest. So to do that, I'll show that step again. We'll go to Graphs and then Chart Builder. Click OK. Then we need to select the scatter plot. So I'm going to select Scatter right here and drag a scatter plot up to the template. I'll put weight on the x-axis and miles per gallon on the y-axis, and we'll click OK. So we can clearly see that there is a downward trend here. As weight of the car increases in metric tons, miles per gallon is also going down in a negative direction. We do have an inverse association signified by this correlation coefficient. Okay, so the first table here was the Pearson correlation. The second one you'll see labeled Spearman's rho. So you don't, for this example, you don't necessarily need it at all, but if normality was not met for the variables of interest, then this is the box that you would interpret. And you can see how similar the values are. Usually a Pearson and Spearman are going to be very similar in terms of the calculation. But there's always a referential test to run given how your data is measured. Okay. And then the other example, we can look at a chi-square as well. So I have two categorical variables here, engine type and transmission type. So we have V-shaped and straight for the engine type, and transmission can be manual or automatic. I'm going to go to analyze and descriptive statistics, and crosstabs. So we're going to run a cross tabulation between engine type and transmission type. You want to go to statistics right here and make sure this box is checkmarked, chi-square test. Click continue and OK. So you can see it's going to cross tabulate engine with transmission. So 7 cars that were automatic also had a straight engine. 6 cars that were manual had a V-shaped engine type. You then come down to the chi-square test table and you interpret this row right here. We can see, based on the significance right here, this p-value is greater than 0.05, meaning that there's not a significant relationship between engine type and transmission type. Okay, so that covers the webinar for today. Just to reiterate, our company helps with every part of the dissertation. So if you have hit a roadblock, please give us a call at 727-442-4290, or you can email us at info@statisticsolutions.com. Now open the webinar for question and answers. If you have any questions, please type them into the chat box. It looks like we have a question from Edward. Edward asks, I am researching environmental, social, and governance rankings. I'm assuming they are ordinal, as many ranking agencies have different ranking measurement scales. Example, from 0 to 100, 0 to 50. Higher rankings demonstrate increased ESG performance. Would you agree that these numerical rankings are ordinal? If it's ranking all the agencies from 1 to 500 or 1 to 100, if it's ranking them in any particular order, then it is an ordinal variable at that stage, because everything has an order to it. So yeah, I would say Spearman correlations are probably your best bet if you're using correlational tests. We have a question from John. Can you turn non-normal data into normal data by taking logarithms of the data values? That's a good question. There are ways to transform the data so it does resemble a normal distribution, and there are many ways to do it. You can take logarithms. You can also take square roots. You can take square the variables. There are many different transformations to attempt. I try to avoid it because then it shifts the interpretation of your regression or your correlations. You're then interpreting it in terms of a log as opposed to what the raw data is. So I try to avoid it, but it definitely is a solution that some people attempt. They try transforming the data. I'm wondering if you could do correlations on the same sample, but then group that sample into, say, 3 groups and do correlations on the group. Yeah, you can do that. So that's typically, I can show you an example of that in SPSS, if I'm understanding your question correctly. So you did miles per gallon in weight, but say you want to split that by transmission types. We want to look specifically at manual cars. Is there a relationship between weight and miles per gallon? And likewise for automatic cars. The way you do that in SPSS is you go to data and then split file right here. And trying to find where that window popped up on my computer. Here it is. We'll put transmission type in this box right here, organize output by groups. I'm going to select transmission type. And whatever analyses we run now, after running this command, it's going to look at it by manual and automatic separately. I'm going to enable the split file and then go back into the correlation we ran. And you can see at the top here, transmission type is automatic. So for automatic cars specifically, we can see the sample size is 19, not 32. Of the 19 automatic cars, there is still a significant inverse relationship between weight and miles per gallon. Likewise with manual cars, it's even a stronger association potentially. Does that make sense? Yep, you're welcome, Edward. Thanks for joining. What type of data need the test of normality? It's any variable that is a continuous measurement. So I've touched on that earlier in the presentation. Let me open that up. Okay, so remember parametric techniques like Pearson correlations, we're making the assumption that the data follows a normal distribution. So if you have a continuous variable, that's when you need to check for normality. And I talked about continuous variables right here. Any variable that falls in a continuum, like test scores, if it's from 1 to 100, or it can, SAT scores even go up to the 800s. I think it's 1600 now. So things like that, scores, temperature, height, weight, BMI, composite scores, those are the types of variables you want to check for normality. Okay, so what if the groups are based on the relationship of the two variables? So for example, two test scores, and it groups students into those who have better scores, those who have worse. The same logic would apply if you want to see by group, then you do the same split file command. I just think that in this specific example, it's kind of skewing the data, and that you're grouping the people into those who have better scores and those who had worse scores. So that's going to manipulate how your correlation comes out, because test scores are your variables of interest. So I probably wouldn't do that. I would look at the sample collectively in this example that you provided, as opposed to splitting them up, because your categorical grouping is based on how they scored. So I probably would not do that. I would look at the sample collectively and not split them up. Does the p-value have any significance, or does p-value significance have any relevance with the R value? It's highly dependent on the sample size. So if you have a large sample size, like thousands of cases, you can get a significant result with a very low correlation value. So you could have a correlation value of 0.02, but if you have thousands and thousands of cases, then your p-value might still be. Generally, the stronger your correlation value is, so the 0.24 you provided, the stronger that value is, and the closer it is to 1, the more likely you're going to find a significant result, meaning your p-value is going to be lower the higher your correlation coefficient is. An ESG score be considered a continuous variable? I don't think so, because it's ranking all the different agencies. So it's not truly a continuous variable. Every agency is being ranked. I would venture to say that it's an ordinal variable, not a continuous one. If you have the split file or have set a filter, is there an indication on the screen that you have done this? Or must you remember that you did split or applied? When you run the analyses, you'll want to look out for where you see these filters. So no matter what test we run, I can do descriptives as well. On here, still have the split file on, so it's going to filter it. You'll see transmission type equals automatic. This means the split file is still on. And you'll see it at the bottom of the table as well as a subscript. The transmission type, everything in this table is in reference to the automatic transmission type. Just to be safe, I would constantly double check split file. You'll see current status here says organized by transmission type. If you want to turn it off, hit reset at the bottom here and OK, then double check it again. Current status analysis by groups is turned off. So look out for the headers at the beginning of every analysis, the subscripts at the bottom of the table, and I would double and triple check the file command, see if it's on or off. Okay, do we have any other questions? Some great questions today. Any additional questions? You're welcome. Thanks for joining us. You're welcome, John. Thanks for joining, Angela. Thanks for joining, Sydney. Just for reference in the future, we do have on our company website a list of upcoming webinars in addition to past webinars we have conducted. So this is our homepage, statisticsolutions.com. And when you come to the webinar tab right here, you can select upcoming webinars, and you can see the webinars we will be reviewing in the future. So we cover a variety of topics, literature review, introduction, qualitative topics, quantitative topics, mastering your quantitative methodology, how to present results. So we have a lot of good topics on the horizon. We do 8 topics a month. 4 specialists do 8 topics altogether per month. So check these out. If you've hit a roadblock or just need some additional guidance, these can be very useful. Then we also have our archive library right here, which has all the webinars we have done in the past. So you can watch the recordings of these as well. Melissa, just put the links to those webinar archives and upcoming webinars. You can look at those as well. And we will be sending everybody a recording of the presentation today. Do you have any additional questions? I'll stay on for a few more minutes to see if we have any final questions. Any additional questions? All right, everyone. Thank you for joining us today for the webinar. Come join us for the future webinars. And if you have any questions, please reach out. You can schedule a free consultation with Janine, and she'll guide you through the process, provide you with a quote, and outline the assistance that we can provide. Can we have a certificate for CPD points? I don't believe that's something that we provide in these webinars. We do provide a recording, so we will be sending that to you tomorrow. Yeah, let us know if you have any questions, and have a great evening. Take care. Bye-bye.